welcome back to another professional prep video. So, in this video, I'm going to be talking about motion. So, what do I mean by that? Well, I mean position, velocity, and acceleration. So, position function defines where your position is, where you're at, your position on a certain time interval. For us, I'm just going to do at all times t, our position, would be written like that. X of t, and you have your equation. That would be the position for time t, and for us, we're going to do it at all times t. Sometimes you'd see an interval for 0 is less than t is less than 12 or something along those lines. So now let's talk about velocity. So what is velocity? Velocity is very similar to speed. It's not exactly speed, but very similar to it. In other words, it's the rate at which the position is changing. And by now, we know what rates mean. That's right. Velocity is the derivative of position. New way to think about it. And acceleration, the rate at which the speed is changing. Maybe by now you expect it, but A of t is going to equal v prime t. And there we go. So that's how these functions are going to be defined. Let's try a quick problem. So say that x of t equals 3t squared minus, just so we don't get confused between my t's and my pluses. So I know I need to differentiate them more, but I'm just going to use minuses for now. Minus 6t minus 17. And say that our question is to find what a of 5 equals. So let's go down this little ladder here. So we have our position function. Next, let's find our velocity function, or the derivative of position. That's going to be 6t minus 6. The 17 is obviously a constant. 6t is going to be 6. And the derivative of that, to give us acceleration, is actually just going to be 6. So maybe this is not the best example here, but the acceleration at all times t is going to be 6. So our answer to a of 5, we don't even need the 5 to answer this question, but it's going to be 6. And the last thing I want to do is talk about speed. Speed is very important for these motion problems, so I just want to give a quick shout out to speed, and we can go over it real quick. So speed, first of all, speed is the average value of the velocity function. Speed just can't be negative. That's why we take the average absolute value. Speed is usually in some sort of units like miles per hour. I should probably specify that. Position is usually in something like miles or inches, one of those. Velocity is usually in miles per hour or feet per second or something like that. And acceleration is usually miles per hour or miles per hour squared or whatever, feet per second squared or feet per second. That's all the same thing. But yeah. And most importantly for us immediately is when speed is increasing. So speed is increasing if v of t and a of t, in other words, velocity and acceleration, have the same sign. What do I mean by sign? I mean, if they're both positive, they have the same sign. If they're both negative, they have the same sign. And if one is positive and one is negative, or vice versa, that would mean that the speed is decreasing because they don't have the same sign. So that's our little spiel on speed. I just want to try a quick problem. So based on these equations for position, velocity, and acceleration, when is the speed increasing for this function? So we immediately go to velocity and acceleration. Our acceleration is always positive 6, which means it's a positive sign. So since we need the same sign for velocity and acceleration for it to be for the speed to be increasing, we immediately look for the velocity function to be positive, since acceleration is positive. So I'm going to solve a quick equation here. 6t minus 6 equals 0. This should be your first step. And our solution is t equals 1, which means the velocity function changes time at 1. So what I do, I like setting up this little sign chart here to track the sign of the velocity function. When t is less than 1, the velocity is negative, and when t is greater than 1, the velocity is positive. That's all I do with this little sign chart. That's all I really have to know. Sign charts will be important for us a little bit later too, but that's all we really need it for here. And we know that the velocity is going to be positive when t is greater than 1. And that's precisely what our solution to the problem is going to be. T is greater than 1, and if t is greater than 1, the speed is increasing. That's our solution, and that's all that we need to do. And boom, we have solved this motion problem. So that's all I have for you for this video, but please email us or leave a comment if you have any questions. If not, I will see everyone next video. Please make sure to subscribe to our channel, and have a great day, everyone. Thank you so much.